Hi everybody, Mrs. Danielson here, and today we're going to talk about set and interval notation. I know it's the beginning of the course, but this is something we're going to use for the rest of the class. We'll refer back to what we learned here. So we're going to pay attention today, and we're going to learn something that's new for most of us. So we're going to come over here to our iPad, and we're going to get started. We're going to be doing set and interval notation today. One thing that's nice about a video is that if you do find yourself kind of drifting off or you get a little bit confused, right, you can always pause the video, right, and you can rewind it, watch that part over again, or you can always take a break, pause the video and walk away for a few minutes and come back and start again. Okay, so really take advantage of the fact that we're watching this video and use that to your advantage, all right? Okay, so set and interval notation. First, let's talk about what a set is. What does that mean when I say a set? Well, that means if I have, say, let's say a set of integers. Okay, we're going to call it A. And in that set, I have some numbers. Let's just do 1 to 6. Okay, so I have these integers, and they're in a set. Okay, so A is the name of my set. And 1 through 6, those are the elements in my set. So those are the elements of set A, all right? I have a couple different notations that I could use here. I could say that, let's say 2. I know that 2 is an element of set A. I could write that this way. Oh, excuse me. I said 2. 2 is an element of set A. So you got that like E, that kind of funky looking E, that means it's an element of set A. Now 7, for instance, it's not in there. 7 is not an element of set A. I could say 7 is not an element of set A. Okay, so we have is an element, is not an element. Okay, another way I could write that set 2, you know, right there I have it listed as like every single element. I had to write out 1, 2, 3, 4, 5, 6. If it was like a really long string, say 1 to 100, I mean, you're not going to want to write every single number 1 to 100. So another way you could do it is by just using an greater than or less than, use a range, and that way you don't have to list every single number. So the way I would write that would be to use the brace again, and then I would say all x's such that, okay, that little up and down line means such that, okay, so all x is such that x is greater than 1 and less than 6, oh, greater than or equal to 1 or less than or equal to 6, and x is an integer, right? And then a brace. Okay, we had to express it's an integer. Otherwise, it could be like 1.5, and it could be 4.2. It could be all those things in between 1 and 6, but we only want the integers in this case. Now, for this example, that maybe isn't really necessary because just 1 through 6 is pretty easy to write, but you could see that if it was every integer between 1 and 100, right, it would probably be easier to use this way of expressing my set. Okay, all right. A couple more little shorthands or different ways of writing things. Let's say I have 2 sets. I have a set S and I have an ST and a set T. Okay, let's go ahead and just write those down. I'm going to just make up a couple here. I have a set S, and it's 1, 3, 5, 6, and 8. And then let's say I have a set T, and it's 6, 8, 9, and 10. Okay, so the first one is I can have the union of the 2 sets. So the union of the 2 sets means all the elements from both combined into one set. And the way I would write that is with this U, right? A U that's pointed upward. And I kind of remember that by thinking like it's kind of like a soup bowl. Like if I took all the elements from both sets and put them in the soup together, that would be a union. So this is my union or a soup bowl, right? And that combination of both is just going to be all the elements that occur in either. If you have a number or an element that occurs in both, you don't list it twice, just list it one time. So like in this case, I have a 1 and a 3 and a 5, but notice the 6 occurs in both sets. I don't list the 6 twice, just one time, okay? Same thing with 8. 8 occurs in both sets. I don't do 8 and 8 again. I just write 8 once, 9 and 10, okay? And that's called a union. The union of both sets, okay? Another one is the intersection of the two sets. And the intersection is the numbers or the elements that occur in both. Okay, that's like an upside down bowl. It's not gonna have nearly as much in it, right? I mean, if you took a bowl of soup and you turn it upside down, what's left in there? Not much, right? Because most of it falls out. Okay, so what's left in the bowl? Just the stuff that's in between the two or occurs in both. And in this case, we have two elements that occur in both sets, just the 6 and the 8. Okay, so 6 and 8, a much smaller set, right? And that's the intersection. Oh, I didn't give myself much space there. Let me back up, give myself a little more room. That's the intersection. Okay, so union, intersection. What if there wasn't anything? I mean, what if there was no elements that were part of both sets? Then how would I write that? Right, let's just say, for instance, there was none. Okay, let's kind of make it up. Then you would write it like that. Okay, and that's an empty set. Okay, that would be if there's no elements that occur in both. An empty set. Okay. Okay, so there we have a couple ways to write your sets and unions and intersections. Okay. All right, so now we're going to talk about what an interval is, right? How we write that versus set notation. Okay, let's say we have x less than 2. There are different ways to write that, right? The first way we could write that is just by graphing it on a number line. So if I had a number line, right, that would look like a hollow dot or filled in dot. It would look like a hollow dot because we don't actually include 2. So we would have a hollow dot at 2 and its values of x less than 2. So we would have an arrow pointing that way. Okay, so that part we're good with, right? We know that from our previous classes. Now there's two different notations that I can use, okay, to show this x less than 2. Interval notation and set notation. This is our goal for today, okay? First, let's do interval notation. And then we'll do set notation. Okay, interval notation, just take the values that are included in that expression, okay? And if it includes the value on the side, you do a bracket. If it doesn't actually include that number, you use a parentheses. So in this case, okay, the right-hand side doesn't actually include the 2. Okay, it goes up to 2, but doesn't actually include it, so parentheses. Okay, and then on the left-hand side, it's kind of going on forever, right? It's going on to infinity. Okay, so we write that as negative infinity. Negative infinity to 2. Okay, parenthesis on 2 because it doesn't actually include it. Okay, when we're talking about infinity, we always use a parenthesis for infinity because it doesn't make sense to actually include infinity. I mean, can we actually ever equal infinity? Doesn't really make sense to actually equal infinity, never reach it. So whenever we use infinity, we always use parentheses. Okay, so that's what interval notation looks like. Okay, set notation is going to be our bracket. Okay, and you're going to use all x's such that, like we used up above. Okay, and then you're just going to use your inequality. All x is such that x is less than 2, like that. Okay, now right now you might be kind of thinking, well, wouldn't we always just use set notation? Right? You're just putting brackets on it, okay? Why would you use interval notation? And trust me, this does come into play a little bit later in pre-calculus where interval notation is very important, okay? Let's do another one. Let's say x greater than or equal to 2. Okay, so it kind of helps to visualize that in the number line. Right, we have 0, we have 2. And again, you know, if I'm going a little fast, you know, just go ahead and pause, catch up a little bit, rewind if you have to. That's something that's nice about the videos, right? Sometimes I do go a little fast, so feel free to pause and rewind when you need to, okay? Okay, so this one is or equal to 2. So that means your dot at 2 is going to be filled in, okay? And it's greater than, so your arrow is going to be all values greater than 2. Okay. All right, so interval notation. Are we going to have a parentheses or are we going to have a bracket at the 2? In this case, you would have a bracket at the 2. The bracket means that it can equal the 2. Okay, it includes the value of 2 as opposed to the one above where it didn't actually include it. Okay, and then it just goes on for infinity to the right, right? So infinity. And then infinity, you can't ever actually equal infinity, so it's a parentheses. It almost looks like a bracket the way I drew it, parenthesis. Okay, so set notation, all x is such that x is greater than or equal to 2. Okay, we doing okay out there? Okay, let's just step up. Let's get some that are a little bit more complicated, a little more complex. Okay, let's do one where the inequality is on both sides of the variable. Okay, draw in our number line here. So we have a -1, we have a 3. Of course, I'm just kind of sketching it in. It's not necessarily trying to scale. Okay, so we have a bracket, and we're going to have a parentheses because we have one that's equal to and one that's not. Okay, so at the -1, that's going to be a filled in dot because it is or equals to. And then the 3 is just or less than. So that's the hollow dot. It's hard to tell there because my pen is so fat, but that's an hollow dot there at 3. And the x is the values in between. Okay. So what would that be in interval notation? What do you think? What would that look like? Right? We know it's the values between -1 and 3, but where does the parenthesis go and where does the bracket go? Okay. The bracket goes at -1 and the parenthesis at 3. Hope you got that right. Okay, and at least for now, set notation, pretty easy. All x's such that x is greater than or equal to -1 and less than 3. Okay, we're going to do 2 more, and then we're going to be done. Okay. All right, let's do one where it's not the values in between the 2. It's the values on the outsides. Okay, so instead we have x less than or equal to -1 or x is greater than 3. Okay, so it's not the stuff in the middle, it's the other way. How are we going to do that one? So on this one, interval notation starts to get a little bit tricky. Right? So graph that. Go ahead and put a 0 on there and a -1 and a 3. Okay, the empty and hollow dot's still the same, right? We've got the or equal to on the -1, and we have a hollow dot in the 3. But this time, our arrows are going out, not in. Okay, so we'll go ahead and write that in. Like that. Next time I won't do such a fat little pencil, so our hollow dots will look hollow. Okay, and here's where we're going to use that union intersection thing we learned about just a minute ago. Because what this is this is actually two different sets, right? We have one set of numbers that's -1 and less, and then we have another set of numbers that's 3 and above, or above 3. So it's two different sets, and we're going to use a union to join them. Okay, so the first one is -infinity to the -1. Okay, and it includes the -1 because it's less than or equal to, so that's a bracket. And we're going to union that with another set of numbers, which is the 3 to +infinity, and that's parentheses. Okay, so it means we're joining those two sets of numbers and we're not including the stuff in the middle. Okay, it's like saying don't include that -1 to 3. Okay, kind of cool, huh? Okay. And I can't quite fit it in there with my big fat pen, but what would set notation look like? It would be all x's such that, and you're kind of just repeating the original problem, right? X is less than or equal to -1, or x is greater than 3. Okay, we're down to our last one, and then we are good. Okay, you'll be ready to go. Okay, this last one's a little bit of a thinker. Okay, and it's that x does not equal 0. Okay, what is that one going to be? I gotta think about that for a minute before we do it together. That one's challenging. Always kind of a tougher one for people. I mean, we can graph that. I'm sure all of you can graph it. Right? It just means at 0, it can't be 0. So that's a hollow dot. It can't be 0. But it can be anything else, right? So I can go ahead and I can do an arrow to the right. I can go ahead and do an arrow to the left. All that stuff. Just a nice hollow dot right there on 0. Can't be that one specific value. Okay, so how am I going to write that in interval notation and set notation? Okay. What I'm going to do for set notation is I'm going to do the same thing I did above. I'm going to use a union and make it the union of two sets, one that goes to the left and one that goes to the right. Okay, so it's going to be -infinity to 0. And then I'm going to use a union and do 0 to +infinity. Okay, so two sets going in opposite directions combined, and it's excluding that actual value of 0 with parentheses. Now, if I had done a bracket, that would be bad, because the bracket would include the 0. But I use the parentheses, so it excludes the 0. Okay, awesome. Okay, and then set notation. All x is such that x does not equal 0. A little bit easier than the other one. And that infinity sign is just a little ugly, kind of bugging me. There we go. Okay, did everybody get that? All right, so that is our discussion today on set and interval notation. Okay, everybody have a super day. I hope we learned a lot, and I'll talk to you again soon.